Okay, next I will explain more about the introduction of our topic, that is logical implication. The first point, the statement if P then Q is written symbolically as P with arrow Q. The second point, it is also described as P implies Q. The third point, the symbol with arrow means implies. The fourth point, P with symbol arrow Q is read as P implies Q to indicate that Q is the implication of P. Next, logical implication can be proved using other truth tables or rules of inference. And the last one, the notation for logical implication is shown in our slide. Next, I will explain about logical implication by truth tables. One of the techniques to prove logical implication is by using truth tables, where if the implication of statement is a tautology, then the statement is logical implication. For the example, as we can see in our slide, this is the example of the truth table. So for the first point, if P equal T and Q equal T, the explanation will be if P implies Q is true, because if P is true and Q is also true, the condition is satisfied. The second one, P equal T, Q equal F, and the explanation will be P implies Q is false, because P being true requires Q to also be true, but Q is false. The third one, P equal F and Q equal T. The explanation will be if P implies Q is true, because when P is false, the implication is true regardless of Q. And the last one, P equal F and Q equal F. The explanation will be P implies Q is true for the same reason as above. When P is false, the implication holds regardless of Q.
Okay, so now I will explain about example 1. Example 1 is about logical implication by using truth table. So for example 1 is if you are pregnant, then the pregnancy test shows double line. The pregnancy test shows single line, therefore you are not pregnant. For this sentence, the P is you are pregnant and the Q is the pregnancy test shows double line. So we can transform this sentence into the symbolic form is P then Q and not Q implies not P. Okay, so by using truth table, we just insert the P, the value of P and Q is like 0, 0, 1, 1, and by Q is 0, 1, 0, 1. When P then Q, when P is true, Q is false, then it will get true. So in this table we get 1, 1, 0, 1, and then not Q is the inverse of the Q. If Q 0 and then not Q is 1, so 1, 0, 1, 0. Also same like not P, if 0 and not P we get 1, 1, 1, 0, 0. So this symbolic form we get 1, 1, 1, 1. So the last column shows that the implication is tautology, which means the last row is identical, is 1, 1, 1, 1, 1. Hence this symbolic form P then Q and not Q is logically implies to not P.
And now I will explain about table rule of inference. Rule of inference, if P implies Q and P, we can simplify as Q, and the name of the rule is modus ponens. For that, if P implies Q and Q implies R, we can simplify as P implies R. and the name of rule is law of syllogisms. After that, P implies Q and not Q we can simplify as not P, and the name of the rule is modus tollens. After that, if P and Q we can combine them and get P and Q, and the name of the rule is rule of conjunction. After that, P or Q and not P we can simplify as Q, and the rule is rule of disjunctive syllogism. After that, with P and Q we can choose P or Q, and the rule is the rule of conjunctive simplification. And the last, with P we can add another words like P or Q, and the rule is rule of disjunctive amplification, and the rest we didn't use in our subject.
So for example 2, I will talk about rule of inference. So the statement is Ali will jog if and only if Abu jogs too. If Ali is jogging, then he will bring his water bottle. One day Ali bring a juice or not water bottle to jog. Recently Ali is not bringing juice to go jogging. So we need to give the 4 primitive statement using the P, Q and R. So as we know, P is Ali will jogging, Q Abu will jogging, R Ali will bring his water bottle to go jogging, S Ali will bring juice to go jogging. And then we need to put all the premise that we have on the statement. So the first one is P and only Q. P if and only Q. Second, P then R. Third, S or not R. And fourth is not S. So by using the rule of inference, we need to get the conclusion. So we need to have a step, statement and reason. So for the 1, 2, 3 and 4 steps, we just write the premise that we get on the statement. That is the first, P and only if Q, P then R, S or not R and not S. So the fifth one, we just conjunctive simplification the first step, and we will get Q then P. After that, for the 6 steps, we have to disjunctive syllogism for the 3rd and 4th step, and we will get not R. For the 7th step, we just using the modus tollens on the 2 and 6 step, and we will get not P. And for the 8th step, we will use another modus tollens but using the step 5th and 7th, and we will get not Q. So after that, for the step 9, we need to conjunctive simplification again the first step, and we will get P then Q. And lastly, we will get the conclusion, that is we need to modus tollens 8 and 9 step, and we will get not P. And the conclusion is Abu is not jogging.
Okay, next I will explain about the last subtopic for our topic. There is truth value of the primitive statements for invalid logical implication. The first point I will explain is an implication is false only when the hypothesis that is premise is true and the conclusion is false. The second point, if the hypothesis is consists of multiple statements connected, By conjunction, all these statements must be true for the hypothesis to hold true. The third one, the statements forming the hypothesis are called premises. The fourth one, an implication statement with multiple premises and one conclusion is referred to as an argument. Next, the validation of logical arguments can be assessed using rules of inference. And the last one, truth value for primitive statements can be determined for invalid logical implication by analyzing false implication.
Okay, so for the example of the truth value of the primitive statement for invalid logical implication, find the truth value for P, Q, R, and S and T if the following statement is false. Okay, so the statement is Q imply R, and not P or T, not S, and not P and Q implied by T and S. Okay, so one way to solve the problem is by constructing a truth table. The implication statement is false when T and S is false. Therefore, both T and S should be false. Meanwhile, the premise Q implied R, not P or T, not S, not T, and Q. All of them are true because the hypothesis of true. So when the statement is false, we have to get the left side of the left side of the statement must be true. So all of them must be true. Okay, as you can see here, T and S is false. Not S, not T is 1, not T, Q, or Q and Q is 1, Q is 1, Q imply R is 1. Okay, so R is 1, not P or T is 1, not P is 1, and P is 1. So from conclusion, we can get P is false, Q is true, R is true, S is false, and T is false.
For the conclusion, truth table is used to know that two statements are tautology or not. If the statement true, we mark as 1, and if the statement false, we mark as 0. The two statements are tautology if the last column all marked as 1, and if not, the statement is not tautology. And we can look at example 1. And for the rules of inference, we use to find a conclusion of the statement given by using rules that show on the table. Rule of inference. That's all from me. Thank you.